Hello, my dear students. So let us talk about conservation of mechanical energy. What is the conservation of mechanical energy? When there is only conservative force is acting on the system or body, the total mechanical energy of the system or body remains constant. Find mechanical energy initial is equal to mechanical energy final. Okay. Now, so what is the mechanical energy? Mechanical energy is a addition of potential energy plus kinetic energy. So what we can write? Kinetic energy initial plus potential energy initial. This is the initial mechanical energy. Kinetic energy final plus potential energy final. Kinetic energy final plus potential energy final is what? Final mechanical energy. Correct? Mechanical energy is addition of kinetic energy plus potential energy. Initial, final. Okay, so let us prove this. So what is the proof? We know that work energy theorem is given by. What is the work energy theorem? We have seen in the previous lectures. Work energy theorem is change in kinetic energy. Work energy theorem says that work done by all forces is equal to change in kinetic energy. Okay, so work done by external force plus work done by conservative force or work done by non-conservative force plus meaning all other forces if they are present. All work, total work is equal to change in kinetic energy. This is the work energy theorem. We already studied. Yes or no? Right. Now, if only conservative force is present and all other forces are absent, then we can say here what remains then? This work will be 0 because the force is not present. This work is 0 and all other works are 0 because that forces are not present. So only conservative force is present. So work done by conservative force will be there and that will be change in kinetic energy. Correct or not? Now. So let us write for this change in kinetic energy means kinetic energy final minus kinetic energy initial. Okay now this conservative force you take on this side. So this will become plus, here on this side it will go and it will become minus. So if you arrange this term, what you will get? Instead of writing this, I will write plus sign here. And this complete term I am taking bracket. So no change I am doing. Okay, kinetic energy final minus kinetic energy initial plus minus what will back or sign it is there is no change. But what is this? Negative work done by conservative force, and we have already learned that negative work done by conservative force is what? Change in potential energy. Yes or no? So this term as it is, this is change in potential energy. And now at this place, what can I write? Final potential energy minus initial potential energy. Correct or not? So kinetic energy final minus kinetic energy initial plus potential energy final minus potential energy initial. So, if you take this negative minus EI minus UI on this side and these two terms as it is on this side, what we are getting? Kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. And what is this? This is very important expression you must remember. Kinetic energy plus potential energy initial means initial kinetic energy. Kinetic energy final plus potential energy final means final kinetic energy, and these two are equal now. So there is no change in the initial energy and final energy. So total mechanical energy initial is equal to final mechanical energy. So that is conserved. This is what the law says. But this happened when condition is there, only conservative force is present. All other forces are absent. Only then this is possible. So this work energy theorem is all time correct. Anytime you can use, but this mechanical energy conservation you can use when only conservative force is present, all other forces are absent. Only that time you can use this. Correct or not? So, so this law is very, very important. Many questions are there. You can solve it. Okay, using this. So let us solve one simple question and based on this conservation of mechanical energy. A simple question we will solve today. Okay, so note down this first. Note down this first. Okay. Can I this? So what we have to remember? This means this. Kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. Let us take one question. Let us take a body at height h. Let us take a body at height h and drop it. Body is dropped. Body is dropped. Body is dropped from height h. From height h. From height h, body is dropped. Dropped means what? Initial velocity 0. Okay. So let us say this height is h. This height is h. Now what they are asking? Find its velocity. Find the velocity of body. Its velocity just before striking the ground. Just before striking the ground. Just before striking the ground. So velocity of this body, when you drop it, it will go down, and while going down, gravity is also acting in the same direction. So velocity will increases. In one dimensional motion, we have done this. Correct or not? Now, so just before striking, some velocity will be there. Let us say this velocity will be v, and initial velocity will be 0. Body is. So how to find this velocity? Okay. So let us use conservation of mechanical energy concept. So initial kinetic energy. What is initial kinetic energy? Initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. Okay. So this is the initial. This is the final. Initial. What is the initial kinetic energy? What is dropped? Dropped means initial velocity 0. So 1 by 2 mv square is the kinetic energy. So velocity 0. Kinetic energy will be 0 plus potential energy. We know this mgh. We have learned this in previous lecture. mgh is the gravitational potential energy. Correct or not? Is equal to kf. Kf final is what? Now this body has attained velocity v. So 1 by 2 mv square. Okay now plus here. Here look, kinetic energy 0, potential energy initial mgh. And here kinetic energy 1 by 2 mv square, and potential energy is what? Potential energy 0 here because height is 0, and on the ground we assume the potential energy 0 or mgh, h is 0. So potential energy is 0. Okay. So now we want v. So mgh is equal to 1 by 2 mv square. So this m can cancel. This 2 will come here. So 2gh is equal to v square. So from this, what you can write? From this, what you can write? V square is equal to under 2gh. And this we have done in 1D also. In one dimensional motion, we have done this. V square is equal to under 2gh. How we have solved in 1D? Just revise it. How we have solved in 1D? Let us have a recap of that. Look, by using one dimensional kinetic equations, how we can solve? Okay, so take this velocity. V square is equal to u square plus 2as. Let us use this. V is what? V, we have to find out v square. U initial velocity 0. What is dropped? So plus 2 into what is the acceleration? Acceleration is gravity. So minus gravity downward minus into displacement is h. So what is going down? So downward is negative. So minus h. Displacement is h. So v square is equal to minus plus 2gh, and v is equal to under root h. This is by using kinetic equations. This is by using conservation of mechanical energy. Why we are using conservation? My question is, why we are using conservation of mechanical energy here? Because conservation of mechanical energy we have to use when only gravity is present. Yes, here only gravity is present. Air friction they are not mentioned. So body is dropped. This is coming down only due to gravitational force, and gravitational force is the conservative force. So we can use this law of conservation of mechanical energy. So like this, many questions are there you can solve. Okay. So in next video, if possible, we will cover some questions. Otherwise, some additional topic we will cover. So if you are liking my channels, videos, okay, so you just subscribe my channel, forward it. Okay. So good luck.